I'd like to do a brief tutorial on downloading and using ChemDraw. This is another program that Emory provides a site license for and is very helpful in this class and others to be able to draw structures, but also to be able to do some other useful things with those structures. So first of all, to download the program, you can follow the link that's in the syllabus, or even easier is to Google Emory Library ChemDraw, and you should get to this page here, and then you can click on downloading ChemDraw. It will then take you to the website where you can create an account and then download the software. So once you get that installed, you have something that looks like this with a fairly standard chemical drawing interface. So let's go ahead and make one of the molecules from the Suzuki coupling lab here. So I'm going to select the benzene ring, double click to put it on here. All right, and then I'm going to go to the single bond, and let's go ahead and make our carbonyl. I need my double bond. In this case, to make a double bond, you double click. And then I'm also going to need a substituent up here. Now to switch what the atom is, I go over here to the text tool and click on that. When you see it change into a little A, then you know you can do that. Click on it and I can turn that into an oxygen. Or this one over here, we can turn into a bromine. Okay. So if you select the molecule using the marquee tool, a couple different things you can do to it. One is if you go up to the structure menu and you scroll to the bottom, you can actually convert the structure into a name. So if you click on that, it will give you the IUPAC name for any compound that you can draw here. Possibly even more useful for our class, though, is if you go back to the structure menu, and you'll see that it can predict the proton and the C13 NMRs. Now it's important to know that this calculates this very differently than Spartan. In Spartan, it does the actual molecular orbital and other calculations to figure out the right geometry and energy of that molecule. ChemDraw does not do that. It takes the structure that you've drawn, and you can clean it up, the angles and things like that. That's kind of like the broom for Spartan. But it takes that and it calculates an NMR, but instead of doing it for your molecule individually, it's looking at the average of all molecules and the types of substituents that are there. But it's very fast. So let's click on the predict the proton NMR shifts, click on it, and there we go. Here is the predicted spectrum. But if you look down here at what's happening, what it's saying is that there's a hydrogen on a carbon at 7.78, and it started at 7.26, and it said, okay, it's near a benzene, so it shifted it downfield a little bit. There's a carbonyl on the other side of the ring, and then some other just general corrections, which is kind of a fudge factor there. And so again, that's averaged over all molecules. So the actual numbers you get in the bottom may be off, but the relative ordering should be very good. And so we've got the hydrogens of this methyl that are there, and you can highlight any one of these, hover over it, and it'll show you where it is in the spectrum. You can do a similar thing. So if we go back to the first document, and once again, we highlight the molecule, this time we're going to choose to predict the carbon-13 NMR, and there it is. Once again, you can hover over any one of them and see where it appears in the spectrum. I would highlight again that this is averaging over all molecules, so don't necessarily trust the absolute value of the chemical shifts, but the relative ordering should be good. When you are trying to assign NMRs in our class, I make the assumption that you have access to these tools. So you should try to assign it yourself, but then you are welcome to verify using Spartan and ChemDraw.